Good morning to one and all. Today we will see about the strengthening methods. What are all the various strengthening methods available for the structural numbers such as beam, column, and slab. So in last class, okay, I told about the stabilization and strengthening. Stabilization, okay, deals with the process of halting a particular unwanted situation for processing, mainly the stabilization of soil for foundation related structures and to arrest the movement. And strengthening means we are adding the strength or we are increasing the capacity of those structural number to take more loading. Okay, so these are all the some of the strengthening techniques which are available nowadays. Okay, so mainly the jacketing, plate bonding, fiber wrap techniques, composite construction, and post tensioning. We'll see it one by one. Okay, so jacketing. So jacketing means it is a method where the dimensions or the size of the structural numbers are increased by providing additional reinforcement, okay, and providing the shear keys for the transfer of load from the old concrete to the new concrete to make it an uh, monolithic and to take subsequently to take the more load. Here you can see a jacketing of an column. So first of all we should know the structural capacity of the column, and based on that okay, what type of reinforcement and what type of concrete to be provided, so thereby its capacity can be increased. Mainly this type of situation will arise, okay, when the structural adequacy, okay, of that column is less, or in case I am going to increase the number of story of the building, suppose g plus 4 to g plus 6 or 7. In that case, earlier when the designer designed that building is only for g plus 4, now I am going to increase the story so that the columns or the structural number strength has to be increased. Okay, so here you can see a column, okay, with this cross section, initial existing cross section. Okay, in that what we have to do means we have to provide some shear crease as you see visually in this photo, and after that we have to place the reinforcement with okay, the dia of the, okay, rod, main rod, as well as the stirrups to be properly, okay, detailed and designed. Okay, and after that, okay, we have to place the former and new concrete should be placed over that. This is how that new reinforcement place, and this is how the concreting is done. So this is the cross section of this area. Okay, and this is how this jacketing method is done. Okay, so here one important thing to be noted. So many places the jacketing technique are done, where what they will do means they will actually place this okay, the new rod, okay, by drilling a hole in the existing foundation or to the plinth beam, okay, and the tie beam which is at the bottom, and then they will do the concreting work, they will close it. But the main important thing is that we should know the detailing of the foundation, okay, whether it is isolated footing or combined footing, whatever the footing, okay, we provided, we should also know the structural adequacy of that footing also. So whatever the new reinforcement, the new load I am going to give, so that load can be taken by the foundation or not. So if it is not so, then we have to increase the size of the footing. Suppose if the foundation is structurally adequate means, and it can take the extra load acting means, we can just drill a hole and we can insert the reinforcement. Or else, okay, what we have to do means we have to follow this technique which is provided in this picture. So this is a combined footing, a combined isolated, okay, sorry, combined sloped footing, where the reinforcement are added to the foundation also, and then the concreting is done. This is an isolated footing. Here also you can see extra reinforcement, and the width of the, okay, footing also increase so that it can take more load. This is also another situation where, okay, they are providing an isolated footing with the extended reinforcement. So this is very important, okay, to structurally identify the load what it can take, and based on that we have to select the suitable technique, whether to drill a hole to the existing footing or to provide additional reinforcement to the footing and to increase the size of it. Okay, next, similarly in case of beam, so here you can see the pictures how this beam, okay, jacketing is done. Okay, so jacketing means an additional, okay, concrete with reinforcement is provided so that the dimensions can be, okay, improved to take the extra load. So here you can see that new reinforcement is drilled into the slab, okay, and then the main rods, okay, are running, okay, along this length of the beam with the stirrups, okay, drilled into the slab, and then the concreting is done. Okay, this is called beam jacketing. Okay, sometimes we can strengthen both the beam as well as the slab also. So in that case, okay, based on the adequacy, whether it for hogging or sagging, we have to identify. Suppose in hogging the strength should be increased, means we have to provide the reinforcement other things on the top of the slab. Sagging means we can provide at the bottom. Okay, and then, okay, the reinforcement, okay, can we have to drill the hole so that the reinforcement should that stirrups can enter into the top also. This reinforcement are provided, so it should close that loop. Okay, so like this also we can provide so that the extra width also provided for the slab as well as for beam also the dimensions are increased. Okay, next one is for beam column joint. You already know, everyone knows that the critical location in a structural okay, element or the structural building is the beam column connection. So wherever a beam connected to a column, those things are susceptible for failures, even in case of earthquake load or any movements happening or any collapse is happening. The first failure you can notice only in this beam column connection. So it should be stronger enough, okay, that this beam and beam element should be, okay, the damages should be visible only in the beam element. So for that, many IS codes, okay, provisions are provided in this IS code, mainly that earthquake codes and all. They given, okay, many detailings for that. Okay, based on that, okay, we have to always strengthen this beam column connection. So extra reinforcement we have to provide so that dimension of column and beam connecting the junction can be improved, and also along with that we have to provide an X shape, okay, uh, bracings in that. So this S-shape bracings, why it is provided means, suppose if the beam, okay, moves upward means then opposite of that it will take the load, and if the beam moves downwards during earthquake loading means then the opposite of that, okay, bar will take this load. So thereby the diagonal, okay, cracking can be prevented at the joints. Okay, and before going into the plate bonding, you have to know about the failure modes in the beams. So normally if any beam failed means, mainly we can find the flexural cracks, okay, running from the bottom soffit of the beam and it will go to the top. Okay, this is due to the happening of the bending, okay, sagging, and near the column hogging will happen so that the crack will initiate at the top and then it will go towards the bottom. And also you can find some shear cracks near the joints. Okay, this is due to the inadequacy of the stirrups, okay, or failures of the stirrups. So this is the failure mode. So if suppose you consider a beam means, you can find flexural cracks near the sagging and the hogging movement, that means the center of the beam as well as at the supports, and shear cracks near the joints or the near the columns. Okay, so based on that, okay, this plate can be placed. So this is in plate bonding concept. What we are doing means, as I told, the critical locations, okay, mainly at the bottom for the flexural failure, okay, and at the flexural failure due to sagging, and at the top near the columns, okay, flexural failure due to hogging, and at the sides near the columns for the shear failures. So if you fix a plate by, okay, drilling some holes, if you fix a plate without any gap between that plate and the concrete surfaces, properly glued with the epoxy grouting means, then whatever the stress coming to that, okay, particular area, okay, focused, it will be transferred to that plate, and that plate will try to take the load. Okay, this is the concept here. So the plate, so what is the main thing? The gap between that plate and that surface, okay, should not be there, and it should be properly bonded. If any gap is there, then automatically this technique will be failed. So that gap should be properly, okay, filled, and it should be bonded to the steel plate what I am placing it. Okay, sometimes we can provide the steel plate uniformly, or like at the corners we can place it, depend on the, okay, orientation what we are planning, or the person who is involved in this process. Okay, sometimes you can provide, okay, like this, okay, angle sections, and then you can make a stirrups, like steel plate also fixed to that. Okay, so this one is a picture where you can see the in the saw feet they are placing the plate, so to take care of the flexure load due to sagging. Okay, here also you can see how that, okay, rods also, that is rods or a bolt is fixed, okay, to make monolithically the steel plate and the concrete surface. Here this is for a column. Okay, here the column and beam connections. Okay, so different orientation and different shapes we can place it, okay, to make this plate bonding technique to work. So this is in case of beams, sorry, slab. So in the slab, okay, and this is for beams. In beams you can see how it is provided, okay, at the bottom, and this is a beam with the slab. Okay, so near the, okay, joints we have provided, at the sides they can provide, or in a form of, okay, this U shape. Okay, bottom of the sides we can cover, and the top also we can provide it. So this is a picture which shows for an two-way slab where this plate is provided perpendicular to that. In case of one-way slab means where the shorter direction is there, in that in those regions we can place this plates. Okay, so in next class we will see about this fiber wrap technique. Thank you.